All right, we're recording this. I just want to thank John Light for giving so much instructions to us over the last month and how to kind of use R-Siena. And so one thing that we're going to try to do today is just kind of take you through real quickly the whole process so that you can kind of see this. We have a couple new folks here, and that will help them. So the first thing you want to do is have R-Siena. And the one we're looking at is RStudio. And you can see this thing right here that I'm sort of putting here. Everyone needs to have RStudio installed, and that's a free program. And if you click on it, what you'll see is something come up like this. So real briefly, kind of what you want to see here is, this is kind of your workspace that you'll be working in. This area here is really kind of where you're going to be storing your files. So I'm storing my files in something on the C drive called Get Repo RHNets. So you can see that right there, and that goes to home. And this is where this is being stored. So if you kind of do any types of changes, it'll go to a particular place right on your drive. So the first thing, we want to do is basically, we're going to take a look at kind of setup, and we're going to look at kind of running some programs. So that's something that we're going to do. You can see there's lots of different programs here.
Yours was called Git Repo. I think it was all the way at the bottom, Lenny. It's right there, that yellow one. I think that's where you store all your stuff.
There we go.
RHNet.
And there's the RHNet. So, great. Thank you, Ted.
Yeah, the home brings you back to your C drive. And then the arrows pointing forward are folders within the C drive. Home, Git Repo, RHNet.
So one thing that we want to do is, this is on the C drive here, okay? And home, Git Repo, RHNets, which is fine. Everything is going to get deposited in this particular area. So if you go into your drive, it'll probably say something like downloads or documents, and then it'll say Get Repo RHNets. That's where you'll be storing your, and every time you make a change here, it'll just store here. But this is where you're basically going to be kind of operating with R-Siena. And R-Siena basically allows you to kind of, what's interesting about R-Siena is that you can sort of have what's called endogenous variables. So what that means is, you might have behavioral variables, things like recovery, that might occur over time for a particular variable. And you might have social network data, like friendship, that changes over time. And in most analyses we do in psychology, you focus on the social networks, or you focus on like recovery scores over time. What this particular program allows us to do is focus on both of them, so they can both be involved and understand how one influences the other over time. And that is different than most types of statistics for social sciences. The other thing that's different about R-Siena is that you can look at not just individuals, but dyads, patterns of individuals, how someone might trust someone else. So think about this. Say, I trust Ted. That's what's called kind of a tie between me and Ted. And Ted's a graduate student at DePaul working on his dissertation. And I'm a faculty member at DePaul University. So I might, in a sense, be a friend of Ted's. And that's what's called sort of a connection, a tie. But Ted might be a friend of mine. So that's basically called reciprocal. So it goes back and forth. So one is reciprocal, one is one way or the other way, inward, outward, or the other is reciprocal. So that allows us to look at dyads and actually triads too. So I might be a friend of Ted. Ted might be a friend of Liam. Liam might be, because of that connection with Ted and Leanne, there might be a larger chance that Leanne is a friend of mine. So it's really can go up to triads in terms of trying to understand the dynamics of the social networks over time. So those are some advantages of R-Siena. And this is what's called the environment. And right here, you want to make sure you're in RHNets, okay? So once you've done that, you're basically going to have this area, and I already had RHNets, but this is empty. But what we'll show you how to do is basically install it. So right now we're in what's called R-Siena. And the first thing that you want to do is go into run. And you can see up here, it says run R-Siena. That's basically running a program. And to get this thing loaded here, the first thing you do is you basically just click on that. Now, the first time I click on it, it gives me some potential errors. So I just click on it again. And now it'll come up fine. What this has done is basically loaded some of these particular packages into my working environment. That's the environment that I'll be working in today. The next thing is we want to really kind of load the program. So we call this Gabby. And this is a particular program. That program is also located on my C drive. Okay? It's right here. So what the first thing I want to do is load it. And if I click on this little button right here, you see that little green arrow? That turns red. That's showing that it's running. And what happened here is this loaded the whole workspace here. So now we have this thing loaded. And the first thing I do when it gets loaded is I just kind of take a look at some of the files. And one of the key files in here that we look at is something called survey. Survey 1 through 6. And it turns out that we have 1,148 variables. That is correct. So that tells me that if we wanted to look at the survey, see right here where the little cursor is, I can look at these different variables and I can see how do they look over time. And those are basic variables that we can see. And the reason, even though there's 627 observations, some of them are 2. Here's you've got case SID, that's case 1, but here you have 2 people for case. You have 101, 101, so basically we have 2 data lines for this person. So there's actually, even though there's 627 participants, some of them have multiple data sources, baseline, wave 1, wave 2, wave 3, wave 4, wave 5. So the second thing that we kind of look at, if we want, is to take a look at something called, right here, this is fixed covariates. That's another good one to look at. And you can just kind of take a look at, these are the things that you're going to put in the model. Education level, employment status, whether they exited the recovery home for good or bad reasons, or they didn't, or they relapsed. So these are all things to look at, but we can at least find out that there's 627 entries. And that means for every database, every data piece of person's experience, we have 627 participants, and there's 1 covariate for each person. So that just tells us that this thing loaded correctly. And if you want to move the screen, all you got to do is kind of go like this. See this little thing here? That'll just move it. So we're going to go through this real quickly to kind of show you, in a sense, how to run something. Now, if you need R-Siena mod, if you need to run program, we can send it to you. Either Ted or myself can send this particular program to you by email. You can then just put it into that directory that you're storing your programs, and then you can basically have this access. So every time you see this little button here, if you click on it, you can basically run it. And what this is basically doing is it's saying from the very large set of variables in what's called survey, it's picking out these particular ones to put into this particular program that we're going to run. So I'm going to click on this. And if it clicks on it, this is kind of green. It starts going. It's red when it's going. And if it goes successfully, you'll see it go back to green. Okay? So that means it's loading these particular variables. These are two social network variables. And because it loaded it fine, now we can look here. Let's look at here for RS age. Can we find it? So we should be able to find, yeah, you see? So age, and this is BLK for black, education college, education high school, employment, so that these variables here are in here. And that's important to see that. The next thing we're going to do is we're going to basically hit this, and you'll just kind of go down the rows. Hit this, and this will basically turn this, goes from red to green. This is going to create an effect object. Ted, do you want to say anything about this particular line?
The effects well, first the one on 43 created a data object, like you said, with all the fixed covariates in there, and then the effects object takes their interactions and puts them into one file. So then it creates something that shows you all the effects of it. And if you wanted to, you could run the line 60 there, and it'll come up as a separate document on your browser to show you exactly what type of interaction they have, the effects of employment on anything, the rates, the way it was scored. So later on, if you're wanting to do an analysis, it's helpful to come back to here to see which line you're looking at running.
All right. So it did so well that it sort of took me back here. Okay. All right. Well, okay. So the next thing we're going to do is we're going to actually say we want to put these particular variables into the model. We're going to look at the advice network, the loan network, and we're going to look at this thing that's called RF, which is recovery factor. The recovery factor is kind of, in a sense, what we think is it's about maybe a variety of different measures like self-efficacy, hopefulness, things like it sort of measures the person's, in a sense, recovery from substance use. And we have a bunch of scores that come into this variable that's a latent variable, so it's a summary measure, and we have it for their baseline, and then every time we interview them every 4 months. Whereas this social network is how they feel about themselves in the house. So advice network is, am I asking for advice from somebody? So I can be asking for advice, and if I do ask for advice, it's a tie. If I don't ask for advice, then I don't have a connection or tie with that person. So it's basically saying how many people have an advice network in each of these 42 recovery houses. And this is loan, and this is basically saying, am I willing to make a loan? Am I willing to give someone $100 or $500? If I am, I have a tie, a connection, and that's probably a measure of trust. So advice seeking and trust is measured every time across these different waves, every 4 months, as well as the recovery. So we're able to see, does the advice and does the loaning trust influence the recovery over time in this recovery home environment? Next thing we're going to do is, I could click on this. Here's another way of clicking on it. You can basically hit Control, Enter, and that automatically will take this line. The other lines are basically false, so that you don't need to click on them. But if you wanted to just click on this, it would do the same thing. But you can be, tends to get a little bit more reliable results for some reason. And then here, we have a bunch of what's called covariates. So in a sense, we've entered into the model the social network, the two social networks. These are types of relationships. And we've entered into the model, in a sense, the recovery factor. Now we want to say, does some of these other factors influence those things? So for example, for this particular advice-seeking network, does length of time that a person lived in this particular house affect, in a sense? So if you've been in the house longer, do you sort of give more seeking advice? That's the ego. Okay? So here's another piece, and this is kind of, again, for the advice-seeking network. Does the education that you have, if you have a college education and the other person, this is called similarity, has the same college education, do they basically, in a sense, have better advice seeking? So in other words, if you have a similar level of education, are you going to basically do more advice seeking? So each of these different factors has include equals T. So that means we're going to basically accept them. I'm going to do a control enter. You can see that. And there's about maybe 8 of these effects that we're going to do. And each of these is going to basically help us understand, tease apart the effects. All right, so I'm going to click on all the ones I want. And the ones I want are here. So I've just clicked on the ones, and these are false. So I'm not going to click on these. You see what says include equals false? I don't need to click on those. And these are all false down here. These are all things that maybe I've tried, but they did not work. These are other covariates that I tried that didn't work. And then at this point here, we basically want to look to see, what did the model look like? So this is basically saying from period 1 to period 5, this advice seeking, in other words, every 4 months, does that rate of advice seeking, does it increase, does it decrease? This is density. So density is basically how many times we're connected. So I might be connected with Ted, so that's me out degree to Ted. And I might be connected to Gabby, so that's another person. Liam, I might be connected to. So say there's 4 of us, and all of us are connected to each other. So I connect to each of you, then that's high density because we're all connected. We all know each other on this, or we all give advice. So I give advice to Ted, Ted gives advice to Leon, Leon gives advice to Gabby. So that means it's a high dense network. But even though a network is high dense, it doesn't have to be reciprocal. What does that mean? That means I might seek advice from Ted, and Ted seeks advice to Gabby, but Ted basically doesn't have reciprocal advice seeking with me. So in a sense, I seek advice for Ted, but Ted doesn't seek it with me, so that relationship is not reciprocal. It could be dense, it could be connected, but it's not being reciprocated. The same way with Ted and Gabby. Ted could be seeking advice, but Gabby doesn't seek advice for Ted. So that's not reciprocated. So in a sense, you could have networks that have high density, everyone's connected, but networks that don't have reciprocity because people aren't basically going back and forth. It's not in and out. It's not going to the person, the ego to the alter, and the alter back to the ego. So that's a quick understanding. This triplicate in 3 cycles is going on to that 3rd dimension. What it's basically saying is, you know, myself and Ted, I might seek advice from Ted, Ted seeks it from Gabby. Now, because there's already a connection between me and Ted to Gabby, does that make it more likely for Gabby and me to seek advice? Okay, so that's the 3rd person. It's a triplicate. In terms of in-res ego, we just kind of talked about that a little before. In-res is the amount of time you're in basically a recovery house, an Oxford house. And if you're in a recovery house longer, do you basically give more advice? And for here, similarity is if you're close to that person's education level, do you tend to give more advice? And then here's the other network. Here's the loan network. And for this one, we're basically looking at the density, reciprocity, and we're also looking at loaning. So basically, if I'm employed, that's what employ means. But this is alter. That means the other person is employed. If the other person is employed, am I more likely to basically give them a loan? And that turns out to be the case. This is probably the most interesting set of variables because this is now saying recovery. Does recovery change over time? And recovery does change over time. And if it does change over time, is it affected by sex, male, female, black and white, or Latino, or other? And exit, positive exit, or stayed in the house, didn't exit at all. So these things are all covariates related to this recovery, general recovery, which means self-esteem, self-efficacy, hopefulness, optimism. Does that recovery, sense of recovery change? And it turns out that males, everybody seems to recover more over time. But in terms of sex, males tend to do it more than females. Blacks tend to do it more than non-blacks. And those who basically exit positively do it more than those who exit the house negatively. And if you stay in the house, you don't leave the house, you actually do the best in terms of recovery skills, okay? So that's a quick explanation of that. And this is the model. And right here, you would basically run this. And if you want, you can change. This model means pre-vans. This means basically you have run a model before and it has a good structure. If you can put that old model in, and you need to kind of look at this right here and say, is this located in here in your global environment? If it's located in your global environment, you can use it. But if it's not in your global environment, that means you didn't use it. Or you might have used it, but you didn't save this run. So it didn't go back into here, it didn't get saved, and saved here as well. So in a sense, if you already have run something that's worked out well, you can put that in there. And this is just basically running the model. And the way you run the model is you click this. I'm not going to click this because that stops me from doing other things, but I'll click it a little bit later. So this is the critical variable. Running programs is this way. Setup programs is a little more complicated, and we've already set this up for you. So in a sense, you don't have to worry about this. So in a sense, you have statistical program, just like before, you want to load it. And after that, you want to basically bring that into the global environment and start making some changes. What this does is that sets up the survey, all the variables that you are thinking of using, and then the run selects those very specific ones that you might want to work on for this particular analysis. So the setup creates the very large data set that you will have, and the run is kind of very specific variables within the larger network that you need. And just to give you a little bit more information about what some of those things are that you're sort of looking at, yeah, you can see here that we have, in our original variable, we have sex, 0 equals male, 1 equals female. We have race. This is kind of the variables for race. We have employment. These are the variables for employment. And then we try to, in a sense, create maybe binary variables. Or you could, for example, you could say full-time and part-time, and employed is 2, and other income is 3. So you could have 0 through 3. And then if you wanted to, you could make it even a little bit simpler. You could basically just sort of say, take full-time and part-time and contrast that with not working. Or you could do different ways, but that's how this thing gets set up. And this is the code for setting that up. A little bit complicated, something that you can learn about a little bit more, but basically this allows you to create these variables And the covariates that are so important in terms of, you can see here's the list of covariates. That's what this basically does. So in a sense, the setup creates the model and then the run. And once you create the model, you want to, in a sense, save it. And this is where you save it here, right here. And then when you save it, this will save right here in your C drive. And it'll also be available to you in your work environment. Okay, just a little bit more details about what we're doing here. This is an analysis of recovery homes called Oxford houses. And Oxford houses are places where you can live as long as you want if you're trying to deal with substance use disorder. And in some ways, there is a very large network of these recovery homes, and we work specifically with Oxford houses. And there's something like over 20,000 people that live in these self-help residential settings. Every state, every city has them. So one of the things we're trying to find out is how they work. What's the reason that somehow they seem to help people in their recovery? We do know that there's 3 rules that all these thousands of people kind of have to abide by. One is you have to pay your rent, which is something like fair share, $100 to $130 a week. Very easy to pay that amount with even kind of low-wage jobs. Number 2, you have to be willing to not take any alcohol or drugs, illegal drugs, while you're in the house. And 3, you need to basically follow the rules. And if you do that, you can spend the rest of your life in this recovery home. And it's a group of people that are all going to support your sobriety. And one of the things that we found is those people who go into these recovery homes seem to have a better outcome than those folks who don't in some randomized studies. So what we want to do is say, well, what is it about these recovery homes that makes a difference? And it turns out that one of our early studies that Ed Stevens did about 7 or 8 years ago, maybe even more, is that if you have a friend in the Oxford house, you're willing to stay in there about 6 months. And if you stay in the recovery home for 6 months, you have a very good outcome at 2 years. So that's what we're now doing with the help of John Light, Mike Stuhlmiller, and many others. Myra Guerrero's working with us, Megan also, and Ted, and just there's lots of folks who are helping us try to understand what is it that makes the difference in these recovery homes. So it does seem like there's some facilitating conditions, and we want to understand what they are using R-Siena. And what's nice about R-Siena is that the real world is complicated. The real world has feedback loops. The real world is I affect Ted, Ted affects me. But most kind of statistics really just involves one way, where me kind of affecting Ted. But we want to also see if I affect Ted, how Ted affects me. And that's the type of feedback loops and reciprocal systems and dyads and triads that basically this R-Siena can help you understand. What is going on in the recovery home that makes a difference? And we, again, have many, many interesting findings that we're trying to understand. We think that using this particular statistics will help us do that. So that's a little bit of an introduction. We can go over this a little bit more just for some things that you can think about. Say you want to get rid of all this stuff. You see this little thing here? It just clears it. And it says clears it all. So now that's all cleared. So if we want to rebuild this, we can. And remember, we had something called Gabby. So if we go down, we could do it here. We could rebuild it by loading. Or we could do it here. Say we just click on this and we open this up. That will also rebuild it. If we click on this, which is the database, it will then rebuild this. So that this is the environment that we're working on when we're doing runs. So that's just another kind of little piece that's helpful. Now, say you want to, in a sense, get a run, and you want to sort of say, well, what actually happens when a run occurs. Well, here's a variable that basically I'll click on, and say you get this particular there's a run, and what we want to look at is kind of, let's look at a text, kind of, and that basically tells us what happens. And if you click on modified, you can basically see kind of when the runs are that you want to look at. So if we look at this, I just clicked on this, I clicked on this, and this is what basically, it brings it up here, and you can see this is what a run looks like. Convergence ratio, you want to generally have less than 0.2. So this means that's converged well. And this is really what you look at. We kind of talked about this a little bit. These are all the variables. And in a sense, what you have here is networks. This is the networks. Remember, advice seeking and loaning, those two networks. And this is behavior dynamics. Behavior dynamics means another dependent variable, which is recovery factor. So what happens with recovery over time? And the cool thing is, we don't necessarily just look at recovery factor over time or loan over time. We can look at how these things are both influencing each other. So you can see here, this is basically how your advice seeking that other people make toward you, that's the alter toward you, are affecting your recovery scores. And it turns out, this is really a fascinating finding here, that basically, if you have people that you seek advice from that are higher in recovery, your recovery will actually increase over time. Now, that's a pretty interesting dynamic kind of finding, very important, that you would not be able to get with regular statistics. Let's just go over these things right really quickly. You see it says estimates and standard errors. These are called estimates, and these are called standard errors. And basically, if this is divided into this, the standard error divided into this, it's really very similar to a t-test, 1.96. Every time you get 1.96, it's significant at the 0.05 level. And even if it's a little bit less, you can probably say it's probably close. So you want to see if this is small and this is large, that's a sign that it's significant. And you can see anytime when this would go into this for employee alter, it's basically going to be significant. Reciprocity here is really significant. See that? So when 0.12 is divided into 0.80, you're going to get like 4 or 5, or at least a 4, and 4 is way over 1.96. So that means reciprocity, and it's positive, is suggesting that reciprocity is occurring. For those people who are willing to loan one person, that person is willing to loan back. That's what it's saying. Good. Well, those are, again, some of the basics. Maybe at this point I can just kind of see if there's any questions, or Ted, if there's some things that you want to kind of share as well with the group that we have here. This is being recorded, so we'll have this available for others who might want to get a little introduction to R-Siena. I hope that that provides a little bit of that. But Ted, feel free. Is there anything you would like to add to what I've said, or any other issues you'd like to cover?
No, I think you've covered a lot of good stuff. I did forget, give Liam the resource of the videos that we recorded previously. I think that would help him get exactly to where we were, because John Light did a series of videos, Liam, and you can just watch them from the beginning. And now that I think about it, I could get you set up if I just go back and watch that first video to make sure that your RHNet is installed the correct way. So I think that's the only thing that we were getting snag on with Liam, was being able to get his RHNets to do, and like the home get repo RHNets. That part we were getting a snag on, but we loaded the JL utils, and I think Gabby was doing good, and I was running a similar model to what Gabby was running. Did you have something new, Gabby, or were you still working on that previous model that you shared on Tuesday?
No, I didn't have anything new aside from potentially wanting to get access to that. What was it? It was the in-res one for the loan.
Was it the total alter for the loan?
Yeah, that one. There we go.
Okay. Oh, and you just need the script for that, or the one piece of chunk? Give me one. I could do that right now in the text because I actually just did that for.
Okay,
Hold on.
if you need to share, I can sort of take off my sharing and we can let someone else share it, but I'll stop my sharing here.
Okay, if you want, I could put mine up for a second just to
Okay,
show Gabby the.
sure, Ted, why don't you do that?
And
Yeah,
then
let
Ted,
me
if
get
you
out of
can just
here.
email me the text, that would be helpful, and I can insert it and try running it.
Okay. Lenny, I made you the host, so you'll have to make me co-host.
Okay,
Otherwise, it won't let me share.
how does that work? Are you able to get access now?
Get that. Yep. So, Gabby, can you take a look at this and see if that's what you want? You wanted to make sure that this was in there?
So it's the total, it was the in one, because we were talking about loan, how we're looking at the out degrees, but we would want to look at the in degrees instead.
So to get the in degrees, it's just kind of the word IN.
So that's all I would have to change.
IN right before the thing you had. INTOTALT. So tot alt stays the same, and you just put capital I, small n, and that basically gives you that covariate. So all you have to do is take where you have the tot ALT and just add an IN, and that's basically just giving you the in degree for the alternate. So the alter is basically sending their advice to you.
And you said it's small I.
Is that how it would look right there, Lenny? Tot, alt,
Yeah.
IN?
Yeah, just IN, it's capital I, small n, right in front of that.
Oh, capital I.
And that'll run it.
Got it.
And if you're ever interested in finding some of these covariates, you know, that document thing that Ted showed us, you can look at there, but you can also go just to the R-Siena manual. All you have to do is go to Google, search on R-Siena, and just sort of type in something like tot alt, and it'll show you all the things that are tot alt, and then you can sort of see where in tot alt is. So that's another way of getting some of these covariates.
Okay. All right, sounds good.
Yeah. I think that's all I had. I'm running a model at the moment too. So I'm running one similar to Gabby's, but now I might, after this one's done, I'll try doing what you're talking about too, Gabby. Do you still want me to send you the script that I'm running? Or did you get enough from Dr. Jason with the tot alt
No, it's okay.
IN?
I can try it just based on what Lenny mentioned, and if it doesn't work, I can look at the manual too.
Yeah. We could compare results. When mine's done running, I'll send you my results and you can see if they're similar to yours. That's what Dr. Jason and I did for a while. He would run the same model that I did, and then we would compare results. And if they were wildly different, then we knew something was up. But if they were similar, then we were like, okay, we're on the same page.
So what you often find is that the results are, you know, if I use two different computers or two different people, Ted and myself, we'll get slightly different results because the beginning numbers are different. In other words, it's the model you start with. So that's why the model you put in there, to the extent that you've got a pretty good model to start with, it'll just go quicker and it will give you sometimes a little bit better convergence as well as numbers that you can rely on. So it's not a bad idea to try it several times and actually just play with it. See if you get the same results. And sometimes what you do is do one run and then do it again, because you can use that run for the model, so that the model, in a sense, will get you there quicker, and you might actually do much better by just running it again, using the model you just used. Don't change anything. No covariates, no other variables. You just basically put a new kind of model in there.
A previous analysis model.
Yep.
And the reasoning behind that was for the parameters that we keep talking about. Once those are established, and you have like a set of parameters, this side and that side, it's got to be in between one of these. Once that's set, the model will run a lot more efficiently, like Dr. Jason just said. So even if it's the same model and you do a previous to the one you just ran, the parameters in the one you just ran have been set, so it'll make the new model look a lot cleaner. And it just comes out a lot nicer. And then the convergence also, if you get like that one I showed you before Dr. Jason came up with like 4 point something, if I ran it again, it would slowly start going down. But that was just a huge model. I'm keeping it simple now.
So, good. Liam, I'm sure this is a little bit overwhelming in terms of all the stuff we're throwing at you, but how are you feeling so far about what you're hearing?
Yeah, on the contrary, there's actually a lot of relief in observing you go through R-Siena. Thanks for your patience, Ted and Gabby. I know you guys know a lot of this already. I definitely wanted to know a little bit more about the logical relationships of the different models. So it was really, yeah, it was really informative to hear and you talk about that. So thank you, I appreciate it. There's definitely a lot for me to learn, but I don't feel overwhelmed. I'm just kind of excited to learn more.
Okay, and it's okay not to know, and it's okay to kind of try things that don't work. And you know, the good thing is, you know, Ted's available. Ted's doing this for his dissertation. So that's kind of cool that he'll, as he works on his dissertation, he can have both of you kind of help him too, as you kind of maybe do runs and see if you get the same thing he gets, which he'd appreciate. So one thing that Ted's going to have to do very soon is actually go into the data set to make sure his variables he's interested in are in the variables that he wants to look at. So I would say, Ted, that might be the next thing that we work on, is just to make sure that you know, the variables you want are in there, because the setup might need to be brought. For example, psychiatric severity index, which I know you're very interested in, is not currently in that. It's not taken out. So in other words, we have a very large data set that has a ton of variables. The setup selects most of them that you're interested in, and then run will basically select a smaller group within there. So in a sense, there's like almost 3 universes. There's the first universe, which is, it actually gets even funnier because, or more complicated. You've got the social network data set that's in one place. You've got the behavior, the recovery scores in another place, okay? And what setup does is it brings them both together into one very large database. But you have to say which ones you want to put in there. So setup, in a sense, brings in from 2 very large data sets, which ones you want to kind of be focusing on. And once you have that large data set, which is kind of a sphere within this larger one, then the run kind of says, well, for this particular run, you want to just really look at some very specific things. Does that make sense? In terms of kind of, in a sense, it goes from 2 very large data sets that have everything into one setup that basically has the things that you think you'll be working on, to the run, which is then even a narrow section of variables that you're going to actually test out.
Yeah, I think that made sense, Lenny, because you're taking a big database and you're creating data objects with things that you found in the data set. So if you have variables you want to include that are in the data set, you take them down, and then in that one function that we saw you do where it was date object, you create a data object with only the variables you want in there. So it's not, your computer doesn't have to process so much information if you give it a specific model. That's why when I ran that big one, Gabby, with the friendship network and the closed friendship, it's just too many things at once. So it's John Light always says, keep it simple and then start adding from there.
And John Light, just to let you know, is one of the international, national experts on R-Siena, which is developed by his colleagues in Europe. It's something mostly that has come out of sociology. John Light is a sociologist, brilliant guy, and he has been working with us for a number of years, and that's really an advantage we have. But if we have things here that you folks want, let us know, and we'll send you either the setup or we'll send you the run, and we'll send you some programs, utilities and Rnet that you can get going. So we'll help you navigate so that you can actually have a successful experience. And then once you've done that, it makes it a little bit easier to actually do this stuff. Gabby, how about yourself? How do you feel this is going for you? Do you feel kind of getting a little more confident?
Yeah, I'm starting to understand a lot more of the kind of like foundational aspects of it, I think, and some of the concepts, because I mean, originally kind of just jumped right into doing analysis and some of that higher level stuff. So now that, I've been practicing it more, I'm understanding more of like what a data object is and how the effects work, things along those lines.
And that's really what I wanted to do today, was try to kind of look at the big picture so that you could sort of see, because again, it's so specific. It's so easy to kind of get lost in the cloud. And what I'm trying to do it in a sense is in a quick way, but at least give some of the larger issues that could be helpful as one navigates the system. And Ted, we just want to thank you so much for being willing to have a support group going on where people can learn, and you can as well. And I think if any newer folks should join, this could be something, maybe a good introduction tape. The only reason I get nervous about some of the other ones that we have is they can be very technical. And this one was just maybe a little bit less so, which makes it maybe a little bit easier to get through. So I've got my next Zoom call that I'm gonna run to, but I just wanna, again, thank you all for having this new behavior setting. Very exciting. And maybe one day you can even do an eco community presentation if you want. The call just came out where you can talk about, learning R-Siena by Zoom, challenges and prospects. That would be kind of a cool session if you folks want to work on something like that. It'd be kind of fun to talk about our experiences.
Yeah, that is a good idea for eco too. And the call just came out, and all of us could just be on and talk about things we're learning. Yeah, and then before we go, because I know you're going next week, I'll bring some stuff for my dissertation, so maybe we could go through that, and then I could show you all what I'm working on and how I scored it and whatnot.
Fantastic. Okay. Great. Thank you for letting me come in and do this. Actually, I left another meeting that I was supposed to be at so I could be here, so I could just give this overview. So thanks for me jump in. Appreciate it.
All right. I'll see you all next week.
Thanks.
Bye.